So thanks so much for attending our session. This is all about AI Gateway, specifically about Envoy. And we're going to start by basically talk, first of all, about why you need Gateway. Then understand why AI adoption in enterprise, what we see working with all our customers, what people doing there, how it's usually come. Then we're going to talk, about Envoy as AI Gateway. What did we do there, implementation details, and so on. We'll have tons of demo. And we're going to share with you some of our learning. So first of all, we represent ourselves. So my name is Idit Levine. I'm the founder and the CEO of Solo.
And I'm Eitan Yarmouche. The formatting is wrong. Whatever. I tried. I'm a senior architect here at Solo and the AI Gateway lead.
Exactly. OK. So, and should we represent Solo? I think they know.
Yeah.
OK. Solo is a company basically doing a lot of stuff around networking, API gateway, service mesh, and honestly, everything we need to do in order to make our customer and user successful and scaling. OK, so let's start with talking about it. Again, I think all of you know that, but I just wanted to make the point is that, the idea with the gateway is pretty simple. If we were not going to do the gateway, that means that you need to put all those operation code inside your microservices or application. And usually it's not healthy, because then if you have any problem, you need to upgrade a library, for instance, you will need to go and basically redeploy that application. So it's really not healthy to put the business logic with the core business logic of your application. So ideally, we want to separate it. And by the way, by doing this, we kind of nicely working with the persona, because that way the application user only need to work with the core business logic, what they know. They really do not care about security and all the other stuff. And the platform engineering team getting back the power to their hand, they can actually force security, logging, monitoring, and everything else that we need in order to make sure that the application will run well in production. OK, so if we understand this one, let's first understand, do we need a new gateway? Is there anything that we need? Of course, we don't need a new gateway, but do we need is there a new use case even for AI gateway? OK, we can actually use a regular ones. And I think that even in Solo, honestly, it took us time to understand that this is a real thing, right? We're working with our customer and actually have a lot of our customers coming to us and said, we need this. We understood that this is a very different type of workflow. And when you're talking about regular, typical web application traffic, usually the request is very small. It's quick. You can do a lot of queries and parallels that. It's not in terms of processing requests. As soon as it's arrived, boom, it's basically processing it. The time that it's taking to process it is usually milliseconds. That's what we usually see. Similar requests can serve from cache, which means that we're even getting better performance because we don't really going upstream to the application. And the request cost managed within the backend, right? So that's basically what we're usually using until today. But that's not the case with AI, right? If you're looking at AI, usually the request is way larger, right? You're using a lot of, you're using single LLM. You need to usually ping it to a GPU or TPU. So the compute time, there is some gain here. Request wait for available, so they're basically queuing it, right? So basically the request is actually waiting, queuing in the application. So that's interesting, that's different. In terms of verbal processing from again, it's OK, right? For AI, you will expect it to take longer, and therefore second is fine, even minutes sometimes is fine. And this is actually a very important piece, because we see a lot of people actually using in AI models in some places, like for instance, in the request part, or the gateway. That doesn't make any sense. My guys, no one will wait for 2 minutes until they will get the request. So that's really not actually what you need to do. Request often guarantee a unique content. So there's no, in terms of caching, this is not going to work very, very simple. And then last but not least, in terms of traffic routed, it's depending on the request. And that's a very important piece. So if we're looking at all of this, there is some use cases. If you think about it a little bit even more, you understand that we actually need a little bit more logic, and we will talk about way more. We need to understand a little bit more the logic of the request. So maybe it's not enough for us to stay in the layer of maybe 3. We probably need to go a little bit more and understand the request itself. In terms of, so the workloads are different, but it's even more complex. And why it's more complex? Because you also have a lot of people in your organization, a lot of applications, basically reaching out to a lot of models, usually outside the organization, sometimes inside the organization. So there is a lot of traffic coming from everywhere. So it's really, really hard to maintain it. And even if you want, for instance, I don't know, to keep, and we will talk about it more, you want them to go to a specifically a model, and then you want, for instance, to do guardrail there. So then there is a lot of it, and it's just not consistent. Exactly the same problem that we created the gateway for, to try to create a consensus. Okay? So again, I think that the solution here is to put a gateway. All the requests is going to go to the gateway, and it's giving us a lot of power to basically managing everything that's related to cost efficiency, guardrail, semantic caching, and a lot of other interesting stuff that we are going to talk about in the talk today. So here's what we see with our customers. We're working quite a lot with customers that actually is working on real production workload. What we see is that most of the project, or most of the organizations, starting with the public models. They're going theirs. They're playing with this. This is the easiest kind of way to start using it. But then they understand a few things. They understand that, maybe those models are a little bit too big, and therefore also very, very expensive. And also, sometimes they have some private data that I cannot send there. So what do? You're trying to take smaller models and put them on-prem. Okay, so that's a different problem to handle it. Right now, you're running the infrastructure. It's not OpenAI. So how is that going to work? It's showing a lot of different challenges that we need to solve. And then what we see eventually happening is kind of like the hybrid model. So people starting with the public, there's some data that they will continue staying there, right? They will continue to expose those, use those public models, but they're also going to use some internally in their networking. And how is all of this is going to work? There is a lot of stuff that we can do there, and we will talk about a lot of use cases. So again, right now what we're going to do, the structure will be like this. We will start with public model. We're going to explain what the challenge is. We will go use case, then we show you a demo. Then we will move to the next one, the private one. Again, challenge, demo. So that's going to be what we will do next. Okie dokie, Satan, you take over.
All right, so starting from first principles, when we talk to our customers, the first thing that comes up every time is credential management. So we have seen over and over again that as AI adoption explodes, all the teams that are using these large LLM providers are essentially given API keys to access these providers and just reach out to them directly, right? So the apps themselves hold on to these keys. Now, that is a huge problem for many reasons. First of all, how does key management work? Tracking, revocation, refreshing them, right? Client identity is managed now by the providers, which the problem is these providers, they don't care about RBAC. They don't care about, that's not their business. Their business is making the best, the biggest model ASAP, right? And so now these applications are essentially given free rein. So how do we solve this? Well, this is actually a really typical gateway use case, right? Essentially, you use your IDP, right, to issue keys to your applications. This is something that most likely everyone is already doing today. The gateway holds on to the keys to access the LLM providers, and then you essentially create RBAC rules to access those providers, right? So it's the same thing, it's the same typical workflow that we're used to, but just applied to these gateways, to these LLM providers. So that's the first thing that we see come up all the time. So what's next? So now we've gotten to the point where we have taken the keys out of the applications, right? And they're in the gateway. So that's good. Now we know where the keys are. We know what people are using. Awesome. Cool. So now we have prompt management. So this is a whole new class of problem that really only exists for LLMs. So there's a whole bunch of things that can come up here as you start to use these things more heavily. So first of all, you can have governing inappropriate use of prompt submission. So imagine you have vulgar language, you have jailbreaks, right? You need to make sure that as these prompts are making it either to these models, right, that they don't have any sensitive data, that they don't have, that they're not trying to access your databases in some bad way, right? The class of problems is entirely different. In fact, OWASP has released an entirely new top 10 list of security issues just for LLM APIs. OK, so how do we solve this, right? Well, again, it's a similar problem that we're all used to. We're all used to WAFs, right? A WAF is essentially just a guard mechanism that you put in front of your APIs. Now, in the AI world, I think these things are commonly referred to as guardrails. But functionally, it's the same thing, right? It's a set of protections built into the gateway that give you the peace of mind, right, that allow you to set up security rules such that these attacks cannot happen, right? So there's prompt governance. You can screen for unwanted texts and reject, right? You can establish consistency in your prompt context, right? You can inject system prompts to make sure that you tell the system that it has to be kind, it has to be this, it has to be that, right? You can make sure that there's a certain number of tokens. You can reject or even transform the inappropriate content. And this is all extendable, because what we've seen with all of our customers is that this is actually, right after they get the credential management done, the next thing that they're worried about is data exfiltration, numero uno. OpenAI, nobody wants to give them your data, right? That is numero uno issue for the CISOs. So, OK, so what's after that? All right, so now, all right, we've made sure that the keys are locked. We've made sure that nothing bad is making it out. But we still need to, but now we need to figure out, where is all this money going, right? These models are so expensive, whether you're running them privately or publicly. The cost per token is just astronomical, right? So how do we ensure that we can actually charge back, right, the usage to the teams or individuals or business units that we need to, right? So again, a very typical gateway problem where we need to make sure that we have access logging, right? And again, we're using our client identity, our IDP, right? So we have the client identity. And so using a typical access logging format, right, Glue or the gateway, right, can expose the number of tokens used by the request, and then you can add that and the client identity in so that you can correlate the usage. And in addition, you can use typical rate limiting functionality, but with a twist. So again, rate limiting per request is not 100% useful here, because the number of tokens actually has a very large impact on the cost of the request. And so we have a method of essentially using the number of tokens in the request as the rate limiting bucket. And so that allows you to have a control to make sure that these models are not being overwhelmed, and that specific users or specific teams are not using up too much too quickly. So with that in mind, I'm going to do a demo. And this specific demo is going to be about guardrails. So as I mentioned, so let me just apply my config. I'm not going to go into too deep detail about the config, because there's a lot of it, and we don't have a lot of time. But this repo I'm going to make public after the talk. And in addition, I would love to talk to all of you. Please come to our booth. I think we're in the front. Come talk to us. I'd love to explain all this in more detail. It's gone. But it's beautiful, I promise. You've never seen better YAML. Yeah. Yeah. I'm gonna try turning it off and on again. Hold on. Give me a second. What?
Yeah, that's what I was trying to do.
That's what I just did.
Oh, you're almost there.
There's something.
Was there and then he left.
Interpretive dance. Yeah.
This is my YAML dance. Yeah.
Oh.
Hey,
yeah.
All right.
We are live.
This is why I don't do hardware. All right. Cool. So, as I mentioned, right, it's very important when using these public models that your internal data doesn't get leaked. So how do we protect that? Well,
and it's very important that an AI gateway ships with the basic functionality to mask this. Now, at the same time, we recognize that everyone's data is different, right? Everyone's requests are different. And so the first guardrails, the first piece of guardrails that we added into our code was an extension point. Because at the end of the day, everyone's data is different, and we know that there needs to be custom logic to filter out or potentially mask or block the data that you care about. So first of all, I'm going to show off just a quick regex. So, I'm going to tell, this is a bit of a contrived example, but I'm going to tell OpenAI to remove dashes from the following sentence. Now, I'm currently telling it to mask any phone numbers. And so you'll see that when the request comes back, it's actually going to be masked instead of having the phone number operated on. So give that a second. And we see here that, now let me actually pipe that into JQ so it's a bit easier to read. Sorry. Oh, what happened? OK, 1 second. All right, so now you see here that so it says my phone number is phone number. So essentially, that's just our system masking the phone number before it makes it out. And you can do this additionally with social security numbers, emails, so I'll just do that quickly. Oops. And you see here it's the same thing. My email is email address. Awesome. So, but as I said, right, it's really important that we're able to do this in an extendable way. So as a part of this demo, I've deployed a little webhook that is running alongside. And so I'm going to send another request, but I'm going to tell it. Now, in this case, I have set up this header such that I can tell it what to do. I would not recommend that in production. But it makes for a better demo, so I can show you guys how the webhook can react. So I'm going to go ahead, and in this case, I'm going to tell it that it needs to block if it finds any PII. And there we go. So we've got PII detected in the request. Now, I want to take a second before I move on to the next section and explain how Envoy, because again, this talk is all about Envoy, right? I haven't gone into Envoy yet. So the beautiful thing about, here, let me just go back, open up the slides really fast. The beautiful thing about what we're presenting here is how easy, it's almost how simple Envoy made building all of this functionality. If you notice, right, what did I talk about first? I talked about injecting headers, right? Because at the end of the day, authorization is mostly about injecting headers, right? Envoy can do that super easily. On any route config, you just inject headers, right? What did I talk about second? I talked about prompt management. So it gets a little more complicated because we're talking about messing around with the body, right? And so again, Envoy, about a year ago, introduced something called external processing. External processing has been amazing, we have found for Solo and all of our customers, because it's allowed us to implement logic in other languages very, very quickly, and I was even surprised, in a very performant manner. And then the third thing, oops, why did we, oh, sorry, hold on 1 second. And the third thing we talked about was consumption control and visibility. Again, Envoy has a ton of rate limiting functionality built in, as well as a robust access logging system. And actually, to get the token-weighted rate limiting done for this functionality, I had to upstream a minor piece of, like a minor feature to be able to explain to Envoy how much to rate limit on. But again, Envoy having that kind of flexibility built in has been amazing for us. So.
Awesome.
Thanks,
Ethan. So next we're going to talk about private models. So as I said, they're starting all in the cloud, playing with this, having fun, consuming those big language model, but then they want to come back to the infrastructure. And then there is different challenges. So we will start with some of them. So I'll talk about load balancing. So when talking about load balancing, we all know load balancing, right? It's pretty simple. It's basically round robin, right? That's the algorithm, very simple. It's basically evenly spread it around the request. But the thing is that these applications are a little bit different. And there are some processes that are way taking more long time. So you don't want it to do it fair like this, because it will basically queue in the application. And basically, it's not really efficient, right? Think about what's going to happen. Let's assume that you have any GPU and you have a lot of application queue there, but it's time for it, so you're moving it there. The queue there will go longer versus you probably was smarter for you to actually forward it to a different GPU. So that's basically the idea. So what we're doing there, I mean, Ethan can talk about, but basically what we're going to do there is basically change the algorithm on the load balancing. We're going to get a response. We will know the size and the queue of the way the application is basically queuing. We will get it back, and based on this, we will change the algorithm and where we are basically routing. So that's basically everything that related to load balancing, and I think this is actually a very unique feature. I think that the performance will go way faster, and again, you need to understand, when you're going on-prem, you're paying for those GPU. They are very, very expensive. You want it to be very efficient about how much you're consuming it and how you're actually making the consumption really, really efficient. So the same thing, right? But it's not exactly relevant to this talk because we're not here talking about networking so much. It's everything that's related to scheduling. And I think that this is something that definitely we need to attack. So the beautiful of Kubernetes is that it's actually extremely pluggable. So it's really easy for me to actually change per specific pod the scheduling system. Again, when you have GPUs, the thing that everybody is doing is basically try to optimize the scheduler to this GPU. And again, it's different, right? Because it's different workflow. So this is not related to this because this is not a networking. There's no Envoy involved here, but I think this is something that is definitely something in people's mind, and we probably will adopt it, but will attack it. Next, Ethan, you take it next.
All right, so again, now we're talking about private models. So it's even more important for us that we get as much performance out of our models as possible. So let's talk about that. So first of all, what are the challenges that we face? One, we want to provide our models with the most accurate and up-to-date information without retraining. Training models is expensive, it's difficult, it requires a lot of time, right? These are processes that we would rather avoid if possible. We want to be able to inject client-specific and domain-specific context into these prompts, right? You think about the typical use case, a chatbot, right? It's not that useful if you can't get data about the customer. We want to be able to minimize the risk of hallucinations. We've all seen ChatGPT go a little crazy. Don't lie to me. And then we also want to optimize response latency, right? We can't cache like a standard HTTP call, but we do want to be able to somehow cache, right? We want to figure out how we can reduce the latency. OK, so how do we solve this? Well, the first one is a pretty solved problem. It's called RAG, or Retrieval Augmented Generation. Now, the cool thing here is what we've decided is that actually this is the perfect place. The gateway is actually the perfect place to do RAG. So if you think about it, if you're not doing RAG from the gateway, that means that you're giving access. Again, you're giving your applications access to this very private data. And so you need to make sure, right? Again, it's an issue of who has access to the data. So that's RAG. Secondly, is semantic caching. So I mentioned we can't do typical caching, but we can do what's called semantic caching. And that means rather than matching on the exact request, right? Because this is natural language. So you're most likely not going to have the exact same request. So you match on something that's semantically similar. And I'll explain that when I demo it in a minute. And the second is and the third part, actually, I don't like this bullet point, but we integrate with third-party vector DBs for both of these features. So yeah, we don't have a vector DB of our own. OK, so what is RAG? RAG is essentially the ability to inject context-specific information into a prompt. And again, so being able to do it from the AI gateway means that you can change the configuration on the fly, right? It's LLM and database agnostic, right? So you can perform these operations without your users knowing it, right? And without having to roll out any applications. It's just YAML. And semantic caching, just to go over quickly, the traditional caching mechanisms aren't as relevant here. And so we offer semantic caching, both manual and automatic. And this is based on specific customer feedback that we received for the gateway, where essentially, traditionally, you would take a request, and if it's not in the cache, you immediately put it there, right? But what if the AI hallucinated? And then all of a sudden, you've got a bad request in there, or a bad response in your cache for an hour or a day or some large amount of time. So in order to fix that, we allow manual control over the cache. And you can even separate caching by user to ensure no leaking of that sensitive info that we mentioned earlier. And I really like talking about semantic caching because the real-world implications of this are huge. Okay? If we talk about just the command hi, right? You're talking to a chatbot, you say hi, right? That's one token. And then it says back to you, oh, I didn't write it down here, but it says, hello, how are you doing? That's 10 tokens total, right? So per million calls, that's $10, okay? So per billion tokens, you're talking about $90,000, right? So if you have 300 RPS on some simple token count, all of a sudden you're talking about $90,000. So why shouldn't hi be cached, right? Why shouldn't your FAQ be cached, right? There are so many questions that we already know the answer to. Why aren't those already being put in the cache and saving us a ton of money, whether you're running private or public? Okay, so with that in mind, let's move on to another demo. I'm gonna move through these quite quickly because we're running out of time, but let's, alrighty. Okay, so the first one I'm gonna do is semantic caching. So in order to show off semantic caching, what I'm gonna do is I'm gonna ask OpenAI, what is GitHub? And it's gonna come up with some pretty long-winded answer about CI/CD and Git and et cetera, et cetera. So yeah, README files, very, very long. Now, I don't want my users to see that. That's a lot of data. So what I want them to see is GitHub is my favorite website, but I wish it wouldn't go down so often. So what I'm going to do is I'm going to take that and I'm going to throw it in the cache. So let's do that. So we have a little service that we built, which allows you, again, to manually update the cache. So I'm going to do that. Boom, cache has been updated. So let's ask that question again. There you go. And if you notice, it responded almost immediately. So you cut down the response time massively, and we get the response that we want. And again, remember, I said this is a semantically similar cache, so I probably don't have to ask the same question. I'm going to ask it, what is the purpose of GitHub? Again. So as you can see, the point here is that semantically similar questions will get answered in the same way. So with that in mind, I'm going to move on to the next demo. And the next demo is going to be RAG. So before we jump into the RAG demo, I want to show you a passion of mine, and that's French cheese. Now, I found this wonderful blog all about the top French cheeses, okay? And when I'm setting up my chatbot, I want to make sure that they have access to this information. So I've pre-populated a vector database with the information from this article, and we're going to use that for our RAG. So the first thing that I want to point out is the top 5 cheeses, okay? Those being Brie, Camembert, I'm not going to try and pronounce this, I'm really sorry, or this one, or that one, but, but trust me, they're great. Okay. So let's ask it something not related to French cheese, right? What's Steven Spielberg's favorite movie? I don't know. Thank you, OpenAI, that's awesome. Okay, so now let's ask it, what are the top 5 French cheeses, right? That's that question that we care about. That's the information that we have that OpenAI doesn't know about. Boom. As you can see, it has them. Brie, Camembert, and then those 3 that I didn't want to talk about. So perfect. Amazing. All right, so now, with that in mind, let me delete this one so that we have a clean slate. I had something I was going to say, but I don't remember, so I'm going to move on. All right. Okay. And again, the thing that I want to point out specifically here is external processing. So it has made our work on this so much easier. Again, all this being based on Envoy. Do you want to talk about hybrid, or do you want me to?
Yeah, I can start. No, you know what you're doing. My head is exploding.
Okay.
Sorry.
What?
No, my head is exploding.
So the third use case that we talked about, remember, we started with public, then we talked about private, and now let's talk about hybrid. Because the reality is that they're both going to exist. Different LLMs have different use cases, and organizations are already, we see this in our customers, they're running in both places, okay? So what does that mean for us? Well, again, it's a typical gateway problem. We need to load balance, right? Maybe we are running in the cloud, we're running in OpenAI right now, but we've been testing out this local model, and we think it performs better, so we're going to shift traffic over to it. It's just a canary. right? We've seen this before. Super simple. So we're going to show that off. Another one. And you can use that same mechanism for cost control, right? These models are getting too expensive. Let's start shifting over. Let's start shifting over some traffic, seeing how it responds. Let's see how that goes. And the second important mechanism here is failover, right? We talk about regional failover for typical services, resiliency, always having our services up. It's the same thing for AI services, right? For LLMs. We need to make sure that no matter what, we don't have downtime. Now, the interesting thing is, the difference here is that typically when a service goes down, you get a 503, right? That's typically the response code you're looking for, 503, 502, some sort of 5xx, right? But with AI use cases, it's usually actually a 429 because you have run out of tokens for your usage of that model. Right, that's typical with these clouds, with Azure, with AWS, with all of them. And we see this over and over again. So what we have done is essentially we allow you to do standard failover, but on 429s. And this is the most important part of the talk. If we have any Envoy maintainers in the audience, please approve this PR. Thank you. What? I'll take a look. Amazing. Love you. And again, and the last one, very similar to failover, but regional aware routing. Again, this is something that Envoy does super well. It's been in there since the beginning, right? Envoy is so good at endpoint selection, right? Locality aware routing, making sure that you're going to the best pool of endpoints. It's the same thing. It's the same thing. And so what we can do using Envoy is we can enable all of these use cases, which are useful in general, but especially useful for LLMs. And so we don't have time for this slide.
Oh, what is the most interesting slide?
Okay.
I can talk about it if you don't want. It's the most exciting.
Okay, so the last thing that I want to talk about when it comes to hybrid is what we were calling semantic analysis. And what semantic analysis is basically when I don't know who has used ChatGPT here, but often when it responds, it'll give you multiple options. And it says, which one do you like best? Now, what we realized is that we could do that, but across multiple providers, right? And so what we're able to do, and this is with feedback from our customers, is basically combine multiple provider options into a single request and either allow the user, right, the actual client, to pick the best one, or perform some sort of async processing later and decide which one the organization feels is best. So with that in mind, let's move on to our last demo. And this one is going to be failover and load balancing. So I've set up 2 routes for this demo. The first one I'm calling hybrid. And what hybrid does is it has a 50-50 split between OpenAI and a local Ollama model that I'm running. So I'm going to run this query, and I'm going to JQ out the model that it used. So first one we get, GPT 3.5. This one, and now we've got Quen. So the Quen is the local model. And I'll just show, I think this one is actually worth showing the YAML. This is just a typical gateway API HTTP route with 50-50 traffic splitting. There is no magic here. Super simple, and we enable you to do this very easily. Now, you'll notice the backend refs are not using typical services, and that's because there's a little logic added on top, but the fundamentals are the same. And so the next one that I have here is a failover route. And the failover route is going to indicate what I was showing earlier about if things are returning 429s, right? We're going to go down to our last option. So here, what I've done is I've set up 2 OpenAI options, and then if those both fail, we're going to use our local model. And in order to prove that this is working, first of all, we're going to see here that this answer was returned again by our local Ollama model. But if I go ahead and look, I actually have a little service here that's receiving the traffic and returning 429s. And we can see here that there's 2 requests that came in. First was for GPT, where is it? GPT-4o Mini. And the second was for GPT 3.5 Turbo, right? So we've explained to the system that it should try those first before moving on. And with that in mind, I'm going to give it back to Idit to finish off the presentation.
I will wrap up. Come on.
Sorry.
No worries. Yeah. Okay. Okay. So I will finish it quick because my headache is killing me. But when you're talking about AI, there is, I don't know if you're aware of it, but there is this model called the 3H. And basically, when you're starting attacking a problem in AI, the 3H are helpful, right? That's talking about the quality of the answers. And that's where semantic analysis could be very interesting, right? The second one is honest, right? We really need to make sure that there's no hallucination in the models. That's where RAG is kind of like attacking that problem very, very nice. And then the last one is harmless. And that's basically everything that's related to safe and security, and that's where guardrail is basically playing a big thing. So when you're starting a project in AI, keep this in mind and understand that those API gateways actually can help you with each of those H. But I will finish with this slide because I think it's important. So, we talk about what we see with our customers, but I wanted to show you what we usually see in the beginning when we started working with them, with customers in enterprise. There's a lot of POC out there. People are starting and they're POCing and they are very excited and they're getting quickly kind of like a result that are really impressive. But then they want to go to production, right? And what we see is that, and this is what some of Eitan demo show, the man in the middle. These things right now, the AI, there is a lot of involvement with human. You saw the idea, for instance, for one of our customers that we did basically the caching, the semantic caching that we did. There is basically a person on the other side that is going to handle the cache in the beginning, right? This is people. People is going to manage it. So though we kind of very excited about AI, and there's a good reason, we are a big believer in it, we need to understand that right now, the AI that's actually happening in those organizations, it's a lot of human intervention. And I think that this is something that we need to know because it's really, really important. Okay, so I will finish with this. I don't know if you guys saw the keynote, but we just actually donate a pull request, a donation of our gateway. So we have a gateway called Glue. It's a very mature gateway. We have some of our customers there, so they're using it in a lot of their organization. And we basically donated to the CNCF as the name, under the name Kate's Gateway. As part of this, we also going to take the entire solution of the AI gateway that we have and put it upstream as well, which means that this is not an empty repository. There's so many BS in the market right now. People are announcing a lot of initiative that basically has nothing besides marketing. This is not the case. We have some of our customers that can tell you here, we are working them. We are getting them to production. There is a lot of very interesting stuff that's happening right now. And it's very, very educational to us. And we feel that if we're all going to join together as a community, probably can even get more data, right? And basically work on this together. So again, everything that Eitan was talking about, we will upstream. I think that would be very exciting. And we'd love if you will join us to make it even better. So yeah, thank you so much for having us. And hopefully it was useful.